Hey, what's up? It's Hutch here, and we're on Module 9, Lesson 4, which is Comparing Probabilities of Simple Events. Now, we already have talked about that the more trials you do, the closer you're going to get to the theoretical probability. So let's just take a look at what this looks like. We know that the theoretical probability of a coin landing on heads is 1/2. Okay, so in theory, the more trials we do, we should get closer and closer to that theoretical probability. Now, if we only flip a coin one time, well, you can see we have landed on tails. So does that mean that the probability of getting a tails is 1 out of 1 and the probability of getting a head is 0 out of 1? Well, technically, according to this experiment, yes, that is the relative frequency. However, we know that that wouldn't be a good experiment to help us make a prediction because we didn't really do a lot of trials. Okay, as we do 6 tosses, you can see, all right, our relative frequencies are getting closer to that 0.5 mark that we're expecting. We continue, instead of 6 tosses, we do 16 tosses, and we're getting closer to that 0.5 or 50% that we would expect. Okay, we do 30 tosses. Okay. And there we go. We're getting closer to both of them being at a 50% relative frequency. We do 100 tosses, and you can see it's starting to get even closer. And then we do 500 tosses, and you can see finally we get really, really close or exactly to that theoretical probability. Okay, and so this is what's called the law of large numbers. So highlight that, circle it, whatever. Basically, it means when you do a long run relative frequency of an event, it'll approach that theoretical probability as we basically do more and more and more and more trials. Okay, so the more trials, the better when trying to make a prediction about what will actually happen. All right, so let's go ahead and compare some relative frequencies to their probabilities. So Jaden and Nickel, sounds like a coin. That's a cool name. Nickel. Each spin their spinners shown 50 times. They record the results in a frequency bar graph. So what we're doing in this entire lesson is analyzing the bar graphs, okay? And we're going to analyze their actual situation in which they're collecting data, okay? So you have Jaden, you can see it has a bigger 6, has a really small 1. You see Nickel has all equal size pieces. And so all we're doing is we're analyzing that and looking at the data going, okay, well, let's see. Student 2's data, number 1 and 2 are really small. So if I look up here, which one of these spinners has number 1 and 2 being really small? Well, we can see it's Jaden. Okay, so obviously student 2, let's go ahead and label as Jaden. And student 1, all being more of that like equal height, is probably going to be our Nick Hill. Okay, so there is an official right answer based on the data given, and that's all that you're going to do there. The question actually says which graph represents the results. We're going to go ahead and just list their names, and that's fine. So let's go ahead to the apply and check this one out. Okay, it gives 2 scenarios, and you have to find out which experiment can best be represented by this bar graph. So we're going to look at the bar graph. Okay, so let's analyze that first. And so you do have to slow down and just look. Okay, so green is really low, and then we have some high orange, some high blue. So let's go off the extremes on these to help us figure this out. So let's look at the 2 different options. I'll color code them. So option 1, Blaze randomly select 1 marble from a bag that contains red, blue, green, yellow, and orange marbles, but we don't know how many of each one there are. The other scenario is that he spins a spinner with 5 equal size sections labeled red, blue, green, yellow, and orange 60 times. Okay, he's doing, notice he also replaces the marble, selects again, and he's also doing that 60 times. So the amount of times is the same. So what is different? Well, I know that this one has 5 equal size sections. If they're equal size, we know the data should all be pretty equal. We don't know how many marbles are in the bag. And so if we look at our graph, we have to sort of think, okay, well, does my graph look like equal size data? Not really. So I'm going to go ahead and say that this is probably the marble experiment. Okay. Why is it the marble experiment? Well, because there's a lot of range in data. So I'm guessing there's probably more of the orange marbles and more of the blue marbles and less of the green. They're not equal amounts like the spinner. Okay, so that's how you're going to analyze those today. Let's go ahead and do the check, and then we're all done, and you're going to head to the homework and try this out. So we have 2 experiments are conducted, and the results are recorded in the frequency bar graphs below. Okay, so we have graph 1, graph 2. Let's analyze these experiments and see which ones they match with. So I have a number cube, okay, and that number cube is a 1 through 6, and it's rolled 70 times. So I know each number has an equal chance of being rolled. So right away I'm looking at which graph shows equal results, and I think I already have an idea. Let's look at experiment 2 though. A card is randomly selected from a bag, 6 cards labeled 1, 2 cards labeled 2, 4 cards labeled 6, 5 cards labeled 4. So, you know, there's more of the 4 cards. There's 6 of the 1 card. So I'm looking at the extreme situations, and look at this. There's my 1, there's my 4, and there's more of those. So I can start to see, well, these all seem pretty even. Graph 1 doesn't, and it's sort of matching those extremes. So the hint for you, with my little eyeballs here, is look for the extremes. Okay, and that can really help you analyze. So which graph best represents the results that can be expected from experiment 1? Let's go ahead. We'll just say experiment 1 we think is this, and we think this is experiment 2. So somehow you just need to demonstrate that you know which is which. So that's it with that. Let's head over to the practice for today. Like I said, nice and simple, but it is really good practice to be able to compare data and analyze that. So you're going to go through, same thing. I'm not going to set you up with anything. I think you're completely capable of reading these yourselves and trying to match up what goes with what. So you have number 1 there. You have number 2. You have 2 experiments. They want you to answer that question. And then if you take a look at number 3, we have 2 different scenarios, and they want you to identify which graph represents the results of the first spinner versus the second spinner situation. Okay, so go ahead and take a look at those. Those are things I want you to just tackle on your own, and then we can check that together. Let me know if you have any help. Or wow, let me know if you need any help.